Hello, so today's section is on Introduction to Logarithms. To start, we need to first remember what is inverse of a function. And if you think back to the beginning, there was a section on inverse of a function, and that's when we take a function and we swap out the x with the y. We kind of switch them around, and that becomes the inverse of a function. So in the last chapter, we looked at this particular function, y equals to c, which is a base to the x, and this was called the exponential function, or exponential functions. Now, when we look at the inverse of this, so we're going to switch the x and the y, so now it's going to be x equals to c to the y. And instead of just calling this inverse of exponential functions, this is actually what we call logarithmic functions. Or functions, because I guess there's multiple bases. So basically, logarithms are inverses of exponents. And this is how the two relate to each other. So when it comes to logarithmic functions, there's two forms that they're written in. One is the exponential form, which is basically what we've written here. So that's just when you have x equals c to the y. And another form that is written is called logarithmic form. So we're still going to use these same terms, except they're just going to be rearranged slightly differently. So instead, we'll have y equals to log c x. So c, x, and y still have the same meaning, except they're just kind of arranged in a different way. So when it comes to logarithmic functions, basically log answers, when you're looking for log questions, answers what or is the exponent. So that is kind of the unknown that we're looking for when it comes to logarithmic. So the output is actually the exponent, okay? And the input is actually the value of your base to your exponent. And you're trying to find out what the heck is my exponent. This next section here, we're just going to be practicing kind of switching from one form to the other. So we're going to start with this, which is in exponential form, and we're going to switch it to logarithmic form. So just to point out the three different parts. So in this particular case, the 6 is the c, the 3 is our y, and 216 is x. So if we rewrite it in our logarithmic form, just going to scroll back up so we could see it here. So logarithmic form is this on the right. We're going to have 3 equals to log 6, 216. If you write it, that's what it'll look like. So for the next part, the exponent is always going to be the y equals to log our base, which is 4, and the number here, 64. And for our next one here, this time our exponent is 5x plus 2. So we have 5x plus 2 equals to log base is 2, 32. Now on our right hand side, we're going to change from the logarithmic form back to the exponential form. So in this case, this little number here is c, this here is our x, and this number is actually our y. So x is going to be the number equals to c to the y. here we have 81 equals to our base to 4. And the third one here is x equals, oops, nope, it's 1 equals 10 to the x. So one thing that you'll need to be familiar with is something called common log. And basically, this is just equal to log 10. So this is the common one. And what you'll know is in calculators, a lot of the times when is log 10, then it's not even written. So a lot of the times on calculators, you'll just see log. And if you see log by itself, basically that means you're talking about base 10. So just make sure you remember that. When you don't see, when it's blank and you don't see anything there, it basically means there is a 10. Okay? So let's evaluate some things here now. So first we have log 1. Now, we just talked about this. There's no base, or it seems like there's no base. So in this particular case, we're talking about our common log. So this is actually equivalent to log base 10, 1. Now, let's just rewrite it down here. So we know this is equal to x. So if we rewrite it again, we know this is our c. This is actually our x value, and this will be our y, or that exponent that we're looking for, right? So we know 10 to the power of something gives us 1. Now, what number, when is an exponent, will give us 1? In this case, x must be 0, because anything to the power of 0 would give us 1. So the number that we're looking for is 0 in this case. Oops. All right, question B. So log 3, base 3 is 3 to 5. So again, we could say this must equal to some number. And if we write the relationship back to exponential form, 3 to the x must equal to 3 to the 5. And thinking back to exponents before, we know when we have the same base, the exponents must equal. So x must equal to 5 in this case. For our next question, again, let's rewrite it in exponential form first. So 6, we know this is equal to x. So 6 to the power of something gives us root 6. When we have a square root, that can be rewritten as 6 to the power of 1 over 2. Again, since the base is now the same, the exponents must also equal. So that gives us half. Okay, and our next question here. Log base 4 gives us this fraction here, and this again will equal to x. So let's rewrite it out. So we know 4 to the x equals to 1 over cube root 8. Now we know cube root 8, or you should know that 8 is equal to 2 times 2 times 2. So if you cube root it, it will just be 2. So we know 4x equals to 1 over 2. Can we change this to the same base? I think we can. So it will be 2 to the 2, this whole thing to the x, equals to 2 to negative 1. Okay, let's just write it some more. So we know 2 to 2x equals to 2 negative 1. We're going to make our exponents equal each other, since the bases are now the same. So 2x must equal to negative 1. So x must be negative 1 over 2. So in these questions, we can see that when we have something in logarithmic form, sometimes it's just easier to switch it back to exponential form and then solve it as per what we've learned from the last chapter. So last question here. So if log 3x equals to 2, determine log 3 81x. So first we'll need to figure out what the heck x would be. So I'm just going to rewrite this first guy in our exponential form. So we know 3 to the power of 2 equals to x. We probably all know this. So that means x must equal to 9. So since we know x equals to 9, let's put it into our second expression here. So we have log 3 81 times, this whole thing, times 9. And we know this thing must equal to some number. I'll just call this, since I already used x, let's say this equals to some y, okay? So that means we know 3 to the y equals to 81 times 9. Now, you may see that, hey, we could put 81 and 9 to have the same base, and that will make our life a little easier, as we've learned from the last chapter. So let's do that. So 81 could be written as, so we know our 3y. 81 is basically 3 to the 4, and 9 is 3 to the 2. So when you are multiplying two things with the same base, you could just add the exponents together. So we know this is 3 to the 6 equals to 3y. Therefore, our y must equal to 6. And that is it.